So now we have talked about describing function in details. Let's find the describing function for some common nonlinearities which are encountered in real systems. Very oftenly encountered nonlinearity is on-off nonlinearity. On-off nonlinearity is described over here. That is, if the input to this nonlinearity is positive, we get an on signal or an output of 1, and when the input to this nonlinearity is negative, we get an off signal or a signal with amplitude of -1. So how to find the describing function for this nonlinearity? This here more general situation is written. We can have a plus m and minus m. So to find describing function, what we shall do is that we shall apply a sinusoidal signal as input to this nonlinearity and find the output signal. And then once we have output signal, we shall find the fundamental component of that output signal. So here, if we apply this sinusoidal signal as input to this nonlinearity, what will be the output signal? Here the time axis is downwards. This downwards is time axis, and here this axis is the amplitude of this sinusoid. So we have applied this sinusoid as input to this nonlinearity. What is the output signal? Square wave. So from this time instant to this time instant, x of t is positive. X of t is positive. It means that output will be plus m, and from this time instant to this time instant, this input is negative, and we shall have an output to this nonlinearity will be -1. That is shown over here. This is the input sinusoid. As long as this input sinusoid is positive, we get plus m as an output to this nonlinearity, and when this sinusoid becomes negative, we get minus m, and this sequence repeats itself. Clear? So now this graph is the graph for w of t, the output to this nonlinearity. We can write this thing in mathematical way. W of t is plus m for omega t between 0 and pi, and it is equal to minus m for omega t between pi and 2 pi. This time from here to here is pi, and here to here is 2 pi, right? So you have a mathematical expression for w of t. Now you can easily find the fundamental component to this signal. What is this signal? What is this nonlinearity? This is odd nonlinearity, and this function w of t, if we extend it in the negative direction, what is this function w of t? What is it? It's also an odd function, right? So for odd function, what is a1? A1 is 0 for odd functions, and we only need to determine b1 to find the describing function. b1 is given by this expression 1 over pi integral from minus pi to pi w of t into sine omega t d omega t. We need to integrate it from minus pi to pi. What about this signal w of t? This is depicted over here. This signal is depicted over here. What is sine omega t? That is depicted over here. So what will be the product of these two signals? Both the signals are negative, so it will be flipped upwards, and the signal, their product will be positive from here to here as well. And what will be shape of that thing? Shape of the signal, product of these two signals from here to here will be the same as shape of the signal from here to here. So instead of integrating it from minus pi to pi, we can integrate it even if you extend it from minus pi to pi from here, the same will be the situation. So instead of integrating it from minus pi to pi, we can also integrate it from 0 to pi and then multiply that integral with 2. So that is, this thing is the same as 2 divided by pi, and this integral from 0 to pi multiplied by this thing. So w of t, what is that? W of t from 0 to pi is equal to m. We have simply substituted it over here, and then you can easily integrate it. What is integral of sine of omega t with respect to d omega t? That is minus cosine omega t. M is written over here, and then we substitute the limits of this integration from 0 to pi. If we substitute the upper limit, what is cosine of pi? That is minus 1. And what is cosine of 0? That is 1. We shall get 4m divided by pi. So this the describing function for this on of nonlinearity is given by this relation b1 divided by a. b1 we have computed, and a we divided by a. So that is the describing function for this nonlinearity. We have seen that this is function of the amplitude of the input only. It is not function of frequency, and that will always be the case if you have an odd nonlinearity.